Saxon Algebra 1, Lesson 34. Our topic is the greatest common factor. And before we start talking about that, I want to go back and talk about the distributive property. That sounds so fancy. Distributing. You guys know how to distribute. It's when you have something like this, right? Where you have a binomial inside and you've got a term on the outside, and we need to go like this, right? We multiply. And what we end up with is a to the b plus c to the b. We multiply it, right? And we have, oh no, this is not right. This would be ac, right? A times b plus a times c. Okay, sorry. This now is a different form of the same expression. But if we had this and we wanted, we could put it back into that shape, right? We could look at this and go, oh, look, both of these terms have an A. So let's pull that out, put that on the outside, and then we'll just be left with the B and the C on the inside. Does that make sense? That process is called factoring. And what we're doing when we factor is we're looking for the greatest common factor between two terms. In this case, it was A, right? That's the part that matches. We pull it out, and then we just write down what's left inside the parentheses. And we can always test our factoring, because if we did it right, we should be able to distribute and get our number back again. Same for distributing. If we distribute right, then we can tell because we can see, oh yeah, we could factor it and get the same answer. So once you understand that this is a cycle, it's really easy to check your work and be sure you're getting it right. Sorry, I didn't get it right, but you know, I caught my mistake, so that's what matters. So we're gonna practice this process of factoring on a couple examples, but what we're gonna do as we go from this form back toward this form, we're not going to worry about getting the whole answer. We're just going to focus on finding what we call the greatest common factor and identifying that piece of it. Later, we'll add in the step of coming to those, adding those two parts to our answer. So let's take a look at this. Example 34.1. The hardest thing is writing down the flippin' problem. 8z to the fourth m squared p. Sorry, I do this thing where I always have to say it, don't I? Copy it though. All right, this is kind of like this. Two terms with a lot of stuff going on inside of them. We're looking for what they have in common, all right? And that's what we're gonna call the greatest common factor. We're just looking for what they share. We're not going to worry about the remnants until later. All right, so we always go in order. First, we check the numbers. Okay. Well, I can see this is 4 times 2, and this is 4 times 3. So the 4 they have in common, don't they? So I'm going to put, in my collection of things they have in common, I'm going to put a 4. Now, what I'd like to do is go alphabetically so I don't forget anything. So I'm going to go and look at the P's first. This guy's got 1 P. I can even write that there if I want. This guy's got 2. Well, that means they both can give me 1 P to put here in my greatest common factor. Okay? I can't take 2 because he's only got 1. So I have to take only what they both have. Oh, I didn't go alphabetical, did I? Let's go with M's next. He's got 2 M's, he's got 4 M's. All right, so I can take 2 for my answer. His extras, again, this guy's got extra, can't use it. Z's, 4 and 3. All right, that means I can take 3 from both of them and I'll still be okay. So our greatest common factor is 4, I'm reading it in John's order, z cubed, m squared, p. Now, the order is different than John's, but does order matter when we're multiplying? Say it with me. No, it doesn't matter. So I can write this in any order I want. This is the order it was in the book. I tried to be alphabetical, but I guess I forgot that M comes after P. Well, I mean, I got that wrong too, so I'm having a rough day. But that's okay. Everyone makes mistakes. Teachers do too. All right, 34.2. It's all about catching the mistakes and fixing them, right? That's the whole thing. All right, find the greatest common factor of the first 3 times you do this sort of problem. So for lesson 34, 35, and 36, I want you to write it out on your page. After lesson 36, after you do it 3 times, that's kind of my general rule of thumb, you guys. Do it 3 times the long way, then you can start taking shortcuts. All right, minus 8y squared x z to the third, okay? Again, we can put a 1 on any variable that does not have an exponent. We're trying to find our greatest common factor. The numbers, you can probably do that pretty quickly in your head, but I'm going to show you the process if you can't. You can do the prime factors of each, right? 4 is 2 times 2. 8 is 2 times 2 times 2, so I can see they each can give me a pair of 2's, and that means 4. Now I'll go with x. X squared, x to the first power, I can only take 1x. Y, I've got a 3 and a 2. That means I can only take 2. He's got an extra that I can't use. And z, give him a 1. I can just take the 1z. He's got 3, but that's 2 more than the other guy, so. 4x y squared z. Yay. They're kind of fun, I think. Last one. Oh, this one is not any harder, but it's longer. P to the 15th, wow, he is an overachiever, isn't he? Okay, so again, like always, we do the numbers first, then we go alphabetically through the variables. The numbers, again, the easiest way to do it is to write out the prime factors. You can write out a little tree right under here if you want. I can do them in my head, so maybe you can too. 16 I know is 4 times 4, and each 4 is 2 times 2. So this is 2 times 2 times 2 times 2. 4 is just 2 2's, and 2 is just 1 2. So that means the most I'm going to be able to take is just 1. So the greatest common factor starts with a 2. Now let's look at our x's. X squared, x cubed, x squared. That means the most I can take from everybody is 2 x's. Y, there's a y to the 1, y to the second, y to the second, just the 1. P to the 3, P to the 1, and P to the 15th. This guy's crazy, right? But you just take the lowest exponent, right? The lowest one is what goes in the greatest common factor. So our GCF is 2x squared yp. Yep, I didn't go alphabetical. I just went in John's order. Alas. But guess what? That's the right answer, so it's all good. They don't have to be alphabetical. It just helps keep you organized. This is a fun, sweet little lesson that cuts right to the heart of algebra, and we're going to build on it and finish, right? Here we just were discovering the A's, and later we'll figure out how to write this part too. Okay, I'm done. 34 is history. Goodbye.